Hello everyone, welcome to our pre-calculus lesson. This is lesson 28, measure of central tendency, part 1 of 2. So we have two classes on this topic. This is the first class. These are the agenda for this class: mean, median, mode, mid-range, quartile, mid-hinge range, and interquartile range. We'll try to define them and discuss where to use or what is their advantage, plus the calculations related to them. So first thing is, one important thing about the whole class is central tendency. What is the central tendency? What is this thing actually? This central tendency, it means what? It means if you look at some real life data, let's say you go to investigate the age of some students in some specific class. Suppose, let's say you go to investigate the age of some students of class 9. Let's say you go to investigate some students ages of class 9. If you see there are 20 students, and of total 20 students, you will notice that if their average age is, let's say, 15, suppose, then you will see most of the students age is between 14, 15, and maximum 16. Many students will be like 15, 15, 14.5, 14.6, like that. Very close to that 15. Most of the students' age will be very close to that, central value. You will hardly find any student there whose age is, let's say, 10 years old or 20 years old. Very rare, very rare. So most of the value will be close to that central value. This is called the central tendency. The reason is straightforward, because we are looking at some very particular group of students here, group of sample here, group of population here. And same thing goes with every real life situation. Suppose if you try to look at the average income of some people of living in slum, their age income will be somewhat very less, somewhat very less. But if you go to some luxury residential area, their average income of the people living there will be somewhat higher, and most of the people will be close to more or less higher. All of them are higher, will be higher. And so the value wants to stay clustered around with some central value. This is called the central tendency. Okay, cluster around the central value. In this case, in this example, all the values tries to stay as close as possible with the value 15 here. That is the tendency of the data here, which is called central tendency. And how to measure the central tendency? We have some couple of tools, measurement system, like mean, median, mode, mid-range, mid-hinge. These are the measure of central tendency. Let's discuss them. So first of all, mean. Mean actually basically means the arithmetic average, total number of numbers divided by sum of all the numbers divided by number of numbers. Okay. So this is the most common measure of central tendency. We take the average and just then we look at, okay, that's the central value. So all the values are clustered around this value. Okay. So this is the mean, and this is affected by the extreme values. This is affected by extreme. So this is one of the demerits of this system. What is extreme value? What is outliers? So if you look at extreme values, let's see how red color works here. No problem. So extreme value means when you have some value, like all of a sudden, here we have the example. See, 1, 3, 5, 7, these are the data, and all of a sudden you have a value 14. So this 14 will affect all this data very much. Suppose, let me give you another example from our real life. Suppose you live in some locality where most of the people's average monthly income is, let's say, 50k, 50,000. And all of a sudden, if there is some rich industrialist live in that locality, his monthly income is too much, let's say, um, 300 300, or let's say 300k. So you see, this 300k will affect this value all of a sudden. Suppose if you take the average of 3%, one is 50k, one is 40k, one is, let's say, 55k, which is 55k, which is uh, natural in that locality. Natural in that locality, people's income is average, more or less close to 50k. Eh? But all of a sudden, one guy there lives there whose income is 300k, and you will take, if we take the average of this value, then it will be too much, like 300 plus 50 plus 40 plus 55 divided by 1 2 3 4 divided by 4, so divided by 4. So this average of this data comes average of this data comes 111.25 525k. So now if we take the decision based on this average, if we say that, oh, this locality, this people's average income is 111k, 11.5k, then it will be a wrong decision, because this guy here is messing up everything. Actually, this is the outlier. We should not bring this guy with this calculation, because this is outlier. He is too much, he is not the representative of that society. Okay, so this arithmetic mean is highly influenced by the outliers. Okay, so this is one of the demerits, but this mean is most common measure of central tendency, because this is easy to calculate, and most of the time, if there is no outliers, this gives us a good estimate of the central value. Another one is median. So median is if you arrange the data, then mid value of the arranged data is called the median. So middle number is the median. And if you have, so 1 2 3 4 5 data, so you can take the middle data very easily. But if we have 6 data, which is even number, then we have to take the average of middle 2 data. Okay, so if n is odd, the median is the middle number. If n is even, the median is the average of 2 middle numbers. One advantage of this is not affected by the extreme values. In our example, in our previous example, as we said, so one people's income is 40k, another people's income is 50k, another people's income is 55k, another people's income is 300k. Now, if you look at this value, the median is these two values, since they are even number. So 50 plus 55, if you take the average, so average is 52.5k, which is actually a good representative of this data. We can say that, oh, this is actually good. The people of this locality, their average income is 52.5k, which is actually a good estimate of the average of the average income of the people of that locality. So this measurement system, this median, actually is not affected by the outliers. Okay, so this is a good advantage of the median. Mode is the most occurring data in some data set. Okay, so maximum occurring data in a data set. So this is like 1 2 3. So 3 times this data comes 9 comes 3 times, that means this is the mode. So 9 is the mode here. Okay, so the value which occurs the most, this is called the mode, and this is not affected by the extreme value. There may not be any mode like this. There may be several modes used for either numerical or categorical data. Both case we can actually use this system. Now, where it can be several modes. Suppose if we have, let's say in this example, you have 9 comes 3 times, 1 2 3 times. Suppose 5 also comes 3 times, then the mode of this data will be 5 and 9 both. Okay, so sometimes many modes. Suppose if we give here another circle here, 3 circle here, 3 circle here, 3 circle here. So for this data now, the mode will be 5, 9 and 12. Okay, all of them are mode. So mode is the maximum occurring data. So in this case, in this example, last example, 12 comes 3 times, 9 comes 3 times, 5 comes 3 times. So all of them are mode. So sometimes, and in contrast, in this example, there is no mode because all the data comes just only once. There is no maximum occurring data. There is no most often occurring data here. So there is no mode here. Okay. So this is also a good measure of central tendency, because central value actually occurs the most in a natural case, in a usual case. Mid-range. So to find out the mid-range, you just take the maximum and minimum divided by 2 to get the mid-range. Of course, it is affected by the extreme value, because if some values, as in our previous example, as you have seen, if there is some outliers like 40 and 300k, if you take the average, then actually average will come closer to this 300 will take the whole average to its side, because this is a extremely huge number in this case. So it will be affected by the extreme values. Okay, because we take the average here. Largest, smallest, add both of them, divided by 2. Then we get the mid-range. Quartile. So now if we divide all the data into 25%, 25% and 25% and 25%, we can divide them into 4 quartiles, first, second, third. So this is quartile, this is one, this is another one, this is another one. And first quartile is after 25%, second quartile is after 50%, third quartile is at 75% data. This is how they are defined. This is quartile 1, quartile 2, quartile 3. So 25% data is in quartile 1, 50% data, this and this. Total 50% data is in quartile 2, and total 75% data is in quartile 3. This is not a measure of central tendency. Split ordered data into 4 quartiles. As you can see, they can split the data, ordered data, in 4 different quartiles. That means 4 different segments. 25% data here, this percent data here, this percent data here, this percent data here, like that. So ordered, this is some ordered data, 11, 12, 13, 16, 16, 17, 18, 21 and 22. Okay, if we want to let me edit this a bit. This arrow sign has to be somewhat here. This arrow sign needs to go there. Okay, now it's good. So suppose we want to find out the quartile 1, in this case Q1. This is the formula for finding the quartile. Quartile ith quartile equals to I n plus 1 divided by 4. N is here 1, 2, 3, 4, 5, 6, 7, 8, 9 number of data. So you put total how many data you have, 1, 2, 3, total 9 data. So 9, and then 9 is the n total number of data plus 1. This is the formula, divided by 4, and I equals to which quartile you want to find out. Which quartile you want to find out. Suppose in this case we want to find out the first quartile, so we put I equal to 1. So I equal to 1. Then we do the calculation, we get 2.50. That means after second data 1 to second data and half, we will get our first quartile. So this is not like the value. This is the position. Okay, position of the quartile is higher. It will tell us the position of the quartile. Second quartile, similarly, second quartile we will have put 2 here. Third quartile we will have just put, we will put 3 here. I equal to 3 for the third quartile. Okay. This first quartile, second quartile, third quartile, they have some additional application which we will discuss in our another lesson, in the part 2 lesson. Okay, so this is the setup for that part 2 lesson in a sense. Mid hinge. So the middle point of first and third quartile is the mid hinge. Middle point of the first and third quartile. Why it is important? Because this is not affected. This is not affected by the extreme values. So first and third quartile. That means we are not taking the extreme values. Okay, Q1 plus Q2 divided by 2. That is the. In our example, our first quartile was 12.5, and third quartile is 19.5. So we divide it by 2 in this example. 19.2 we divided by 2, then we get that mid hinge is 16. Mid hinge is 16. Okay, so this is not affected by the extreme values. This way it helps. The range is one of the very common measure of this variation. Measure of the variation, very common. We just take the maximum minus minimum, that is the range of the data. Okay, maximum minus minimum. So in this case, maximum is 12, minimum is 7, so we get the range as 5 range. And in this case, minimum is 7, maximum is 12. Again, we get the range is 5. Maximum minus minimum, regardless of how data are arranged. We will not just ignore. We will not ignore the data. We will ignore the data distribution. Just we will take the maximum and minimum. That will be the range of the data. That will be the range of the data. Interquartile range. So interquartile range is the difference between quartile 3 and quartile 1. That is the interquartile range. Quartile 3 and quartile 1. This is the measure of variation, also known as mid spread. Spread in the middle 50%. You know, this is first 25%. This is second 25%, this is third 25%, this is fourth 25%. So our Q1 is here, and Q2 is here, Q3 is here. So between Q3, this is Q1 and Q3. So between Q1, Q3 minus Q1, that means Q3 minus Q1. So this value. So that means it is not this interquartile range. These things don't care about the first few values and last few values, because maybe they are it is possible there are some outliers there in this side and this side. This is possible that in the both side of this data distribution we may have some outliers, you know. So that's why it is also a good measure actually. Difference between the third and first quartile. So we have this this is not affected by the extreme values, as you can see in our data distribution. So 17.5 minus 12.5, which is 5. This is the interquartile range. Just simply quartile 3 minus quartile 1. That will be the interquartile range. These are some practice problems. We'll try to compute the mean, median, and mode for this data sets. Try to do this, or we can solve them during the class time. This is another example of data sets, environmental study, death valley. This is the temperature related. So we'll have to do the calculations related to mean, median, and mode for the ground temperature, for this given data. And this is another example related to the age of professional football players. And this data, these are real data. And we'll try to find out mean, median, mode from this data and explain another question, which one is the best estimate of the data. You can give a try, or we can discuss it. This is 29. So this is tough to. This is 29. This value is 29. 33, 29. Slightly blur here. So give a try to solve this maths, and then we can actually. Oh, blur thing comes for my white writing. This is the thing. See, So yeah, give a try to solve this math from here, and if you don't do, no problem, or if there is problem in doing these maths, we can solve these maths during our class time, no problem. But if you can solve them before the class, that's also good. And that's all for today's class. In our next class, we will discuss, we will extend this idea and bring some new topic there. All right, so thank you all, thank you very much. See you all in the class. Bye bye.